Hi, today we're going to discuss visual development, sensation, and perception as it pertains to motor development. We will go over a newborn's visual development as well as different aspects of perception we encounter in our lives. First, visual development. Bosworth and Dobkins cite that human infants born prematurely do receive and can respond to visual input before term age. That means that the eyes of a newborn are functional at birth but are still developing. For example, a newborn's vision is only about 5% of an adult's visual acuity. A newborn's visual acuity and function develop to an adult level gradually until they are about 10 years of age. At 6 months, vision is about 20/40, meaning that what a normal adult can see clearly at 40 feet, the child must be at 20 feet to see. Notice how the cup on the right is much more blurry than the cup on the left. When a child reaches about 5 years old, their vision is about 20/30. And at age 10, they reach 20/20, or normal adult vision.
Depth perception is the visual ability to perceive a three-dimensional world where we can judge the distance between different objects and understand them in relation to one another. Two sources of depth perceptions are retinal disparity and motion parallax.
One depth perception source is retinal disparity, which is the difference in what each eye sees due to their distance apart from one another. This results in the eyes having their own different angle when looking at something. The closer an object is, the larger the difference in the images seen by the left and right eyes. Focus on the volleyball net post as we shift from the example of the left eye to the right eye. When an object is relatively far, the left and right eyes see more similar images. Watch how the net post doesn't shift as much when seen from a further distance. Here is another example. This time you will be shown the distant images than the closer images. So how different or similar the images from each eye are helps us judge depth. The other depth perception source we will explain is motion parallax. This is demonstrated through movement in how closer objects move across our field of vision much faster compared to further objects. For example, notice the pace of the distant greenhouse compared to the cars across our field of vision. Now compare the line of trees to the Comcast Center. So how quickly an object moves across our field of vision also helps us judge depth. A 2008 article by Haynes, Keller, and McCollum explains that unlike retinal disparity, motion parallax works well for large distances and may be used with only one eye, given that the person is moving at a high speed.
Object perception is understood with size and shape constancy. Size constancy is the perception of objects looking larger when they are closer and looking smaller when they are further away. Shape constancy is the familiarity with the shape no matter the orientation. Combe and Wechsler make the important point as well that one must use additional surrounding visual information in order to understand depth, and that the surrounding information can be altered to emphasize or inhibit size and shape constancy. Here's an example of images that show distorted perception due to size constancy. It looks as if the cup is getting larger when it is being moved closer to your eyes. However, you know that the cup is the same size no matter where it is. The same is true with these images of the car close up and from a distance. In another case, shape constancy is shown in this video. You can see the cup being rotated and fixed on certain points, yet you understand what the rest of the cup looks like. Similarly, when you see the notebook, even though you're only seeing a flat side or the spine, you can understand what the object is and that no matter the orientation, it is still the same shape.
Thank you for watching, and I hope you've learned more about visual development, sensation, and perception.